Hey, what's up, guys? Chung here again. Today, let's take a look at another LeetCode problem and let's continue our dynamic programming journey here. So, this time, number 741, cherry pickup, the first one. Okay, so let's take a look. You're given like a n by n 2D grid representing a field of cherries. Each cell is one of the three possible integers, either 0 or 1 or -1. 0 means you can go through, but there's nothing to be picked up here. And 1 means there's one cherry, and you can also pass through this cell. -1 means mm, you cannot go to this cell. Basically, it's a thorn. It's blocked. Okay. And the interesting part for this problem is that it asks you to starting from the top left corner, and then you can only move downwards, which means you can only move to the right or down. And after reaching the last the bottom right corners, it asks you to move back to the original 0, 0 starting point. Basically, ask you to traverse this 2D graph twice, right? And then you need to uh, basically calculate the maximum value, the maximum cherries you can pick by doing this by traversing this graph twice. For example, here, so at the first traverse, right? It says okay, it says we go down, down, right, right, which will be collecting 4 cherries, and then when we go back, we go left, up, and then left. So basically, with those 2 traverse, we have 5 cherries collected in total. Okay, so and okay, then it asks you to get the maximum total number. So this problem it's obviously a DP problem, but uh how can we convert like this going to one direction then going back, right? So if you think it in another way, so this is as if like you have two person. They both start from the same position here, right? And each person have their own path, right? So it is as if there are like two persons starting at the 0, 0, and each of them will randomly pick a path, and then you just need to calculate the total, right? The total cherries, the maximum total cherries pick those two persons can uh, can collect from this from the top left corner to the bottom right corner, right? So this is like if you guys remember, I think I talk about another version of this problem, cherry pick problem, which is the cherry pickup number 2, right? If you guys remember how did we solve that problem, right? So for that problem, it's the same grade, and so for that in that problem, the only difference is that we don't have this -1, which means there's no place you can go. For that problem, all the nodes, all the cells, they all have like either 0 or 1, right? And the only difference is that we have a robot A here and robot B here, and each one of them can only move to downward. Basically, it can only move to here, 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 or here, here, or here, right? So basically, for each of the robots, they have like 3 scenarios, right? So they can either move to left, down, or right. Same thing for this one, and but they can only moving down. And so for that, it's just like this problem, but the difference here is that both of the player start from here. They're both starting from this from the the 0, 0 here, and the options they have is they can, instead of moving down here, they have only two options instead of three. They can either move to the right or to the or to the down below one, right? So that's we can basically utilize the previously idea to solve this problem, right? And but the one thing we need to notice here is that we have a -1 here, right? So when we have a -1 here, it means that we basically we cannot go through there, right? So with that in mind, for if we reach a -1 place, that branch we need to return the max man the negative maximum number instead of 0. We need to return this minor system max size instead of 0. Why is that, right? Because since we're doing the traversing here, right? If we're returning, if we reach a -1 here, right? And if there's, say they have like some more nodes after this -1. If we only return 0 here, we cannot tell if this place is actually 0 or -1, right? So if we're only returning 0 here, it could also means that, okay, we can continue down this path, right? Which means we could end up getting the unnecessary ones following this path, right? So in that case, every time we see a -1 here, we simply return the biggest number, the biggest negative number here, so that later on, uh, we only return yeah, basically later on we can use this one, right? We can use we'll use this, we'll ignore this like a huge negative numbers in the end. Okay, and another corner case is that I think, okay, actually another like um another like a hint here is that since, so let's say we have a row one and a column one for the player one, and row two, column two, right, at column two. So ideally, right, so ideally we have the R1 plus C1 should always equal to the R2 plus C2, right? And because they can only move to the right and to the down, right? And we're assuming they're when if they this okay, so we're assuming the person cannot keep moving out of the boundaries. They can only move within the range, right? So if they only move within the boundaries of the 2D grid here, basically they will end up at the target at the same time, right? Because either they can choose go to the right, go down, or either go down, go right. But either way, they will always increase their the row and column by 1 each time. That's why it makes that the R1 C1 equals to R2 C2, right? But for our case, I'm gonna use this uh, four parameters to identify one of the state. But in reality, actually, we can reduce these four parameters into three, because we can just use the R1, C1, and C2, and we can simply get the R2s later on, but it doesn't really matter. And okay, so that's that. And the last thing is that if you remember the cherry pick tool here, right? And if these two robots end up in the same locations, which we can only pick the cherry ones. Same thing here, right? Basically, if the R1 R equals to R2 and C1 equals to C2, and we can only collect this cherry one, right? Because we cannot double collecting the same cherries. Okay, so with that being said, I'm going to use like a recursion, like the recursion plus the memorizations, because for me that's more intuitive, because we're starting from here, right? Starting from 0, 0, and then we reach to the end. So we only need to handle the corner case and the base case. So when we reach the end, since we know two people will always reach the end at the same time, which means so when either R1 C1 or R2 C2 is reach the end, all we need to do is we just simply return whatever we have here. Basically, that's gonna be our base. Gonna be our base, right? So okay, so let's try to code these things up. Okay, so we're gonna have a DP method here, right? So and I'm gonna define like okay, like I said, row one, column one, row two, column two, right? And then I'm going to have a memorization dictionary here. And in the end, I simply return I'll do answer here. Answer equals to dp 0, 0, 0, 0, right? So in the end, I simply return the answer here. And I'm gonna also get an n here of the grade, right? The length of grade. Since it's a square, right? So we only need to get one dimension. Okay, so here first always we check if this one is in the memorization, right? We simply return this memorization dot, right? So that's the first one. And mm, and and then a few special cases, right? So the few special cases like if R1 if any of those coordinates are out of the boundaries, we return the biggest negative numbers, which will be basically tell us there's no value, right? There's no valid result. Okay, and okay, so basically if the R1 is greater than n minus 1, right? So that's or R, okay, actually, yeah. Yeah, actually, I can just copy this for those four values, right? R1, C1, R2, C2, right? So if any of them is out of the boundaries, we simply return the negative max size here. And yeah, like I said, another same thing when we same condition when we need to return also need to return this max negative number is when if the grade if either of the players standing at the minus one place, right? That will also give us a signal that says that there's no valid result at this path or at this branch. So we also need to return this value here. So R1 C1, right, equals to minus 1, I think, and or grade R1 C2, sorry, R2 C2 is minus 1, right? So that's the conditions when we need to return this value, right? And if R1, now we also need to check the base case. Basically, when we reach the end, we don't continue. We simply return the last one, the last element, right? The basically the target cell here. Because like I said, because two of them will be reaching this target at the same time, right? Since the player one's here, which means the player two is also standing at the same position here. So in order to only pick up this like cherry once, we simply just return this cell. Uh, so and C1 equals to n minus 1, right? We can either use R1 or C1 because when R1, C1 and C, at the n minus 1, the R2, C2 must also add the n1 n minus 1 n minus 1. So we simply return the grade the grade R1 C1, right? So now so here are the few edge cases, right? Now for all the now for the real logic, right? So first we need to pick up the cherries, right? Mm, current cherry, right? Equals to I'm gonna play it 0. Okay, so for current cherry, basically if R1 equals to R2 and C1 equals to C2, right? So if they are the same place, we only pick up the, the cherry once, right? Equals to the grade R1 and C1, right? Else what? Else we pick up both of the cells, right? R1 C1 plus, right? Grade R2 C2. Because at this moment, even though it's 0, because we already checked if they are minus 1 or not. So at this point, these two cells are either 1 or 0. So it doesn't really matter if it's 1 or 0. But all we need to know is if they are not on the same cell position, we want to try to collect both of the cells, right? Okay, now that's the current cherry, right? So now for the uh, uh, for the next movement, basically there are like since each of the person have two options, in total we'll be having like four combinations, right? So for me, I'm just simply collecting the directions in here, and so it's going to be going down, which is 1 0, right? And to going to the right, it's going to be a 0 1, right? So that's that. So that's why I'm going to have like mm, the four directions. I'll say D1 in directions, and then D2 in directions, right? So you can either do a for loop here, or you can just list those four options, since that's not a lot of coding here, right? And so I'm gonna hit unvar new row 1 equals to uh, row 1 plus D1, right? D1, sorry, D10. Okay. And then I'm gonna copy this thing four times here. C1, right? And 2, 2, 2. C2, C2, D2, 1, right? So that's the updated here. And then we need to get the maximum out of these four options, right? And then we add up we add to the current cherry to give us the final result, right? And so for the next cherries, right? So next cherries, I'm going to initialize it to a maximum. So the system dot maximum. So you have to be careful here. You shouldn't do a zero here, right? Because why you cannot do a zero? Because if it's zero here, you don't know um, if the if the next place is the -1 or not, right? Because if you continue, if you find a -1 here, you will be returning like uh, a negative number here, a huge negative number here, which will means that path is not a valid one. Okay, let me try to finish this. So the basic next cherry, right, gonna be the maximum, right, the maximum of the next cherry plus the dp, what, the new r1, new c1, right, new r2, and the new c2. So we have four options here, and then basically, actually, we don't. We just want to get the maximum out of those four options, right? Four combinations, and then in the end, we simply do a update cherry, current cherry, right? Plus next cherry, right? And then and now the maximum, we're gonna simply update this memorizations with the current value, with the current cherry, right? And then we simply return the current cherry. Okay, so that's the basic logic here, and let's come back here. So about this zero or this negative big number here, right? So why are we using this one, not zero? And if we and because if we are using a zero here, let's say if all the others, they are like, if all the directions, right? If let's say if all four directions, they are they all returned uh, this the biggest negative numbers, right? And then if we're defining this next cherry with zero, then when we do a max, the next cherry will also be zero here, right? But if all of them are the like giving us like this huge number, it means that at this branch there's no valid answers, right? But if we are limiting this next cherries to be a zero, and when we do a current cherries, this thing will also be a valid positive numbers, right? That will be, because basically we cannot tell from this number if it's a valid path or or invalid path. That's why we need to always, basically we try to use like if any of the path, or sorry, if all the path, right? If all the path is a negative one, we also want to make sure the current number is also like the biggest next negative number here, so we can use this basically we can also use this like big negative number to tell us if this state is a valid one or not. Okay, I don't know if I explained that uh, clear enough, but at least that's how I understand this problem, right? So, okay, let's try to run it. Okay, so yeah, this test case passed. Let's try to submit it. Oh, yeah, so like I said, yeah, so basically, and now we have this like DP answers here. Like I said, if this one is a huge number, right, huge negative numbers here, it basically tells us, okay, there's no valid path, right? That's why we need to return a 0 because at this for this test case, there's no valid path from the 0, 0 to the n minus 1, n minus 1. That's why we ended up having this huge number here. Okay. So basically, we return the answer if the answer is greater than 0, right? Else 0. Yeah, so now it passed. Okay, cool. So quick recap here. So another classic, I would say a 3D is or even 4D in this case. But I think, like I said, we can reduce this one from 4D to 3Ds, right? Anyway, so it's a two two players like DP problem. So for two players, it's at least a 3 DP problem, right? Basically, and the key for this problem is that we should ignore the going like from top going this one way and then going back. We should convert it into instead of one person traversing this like graph twice, we should like try to have two persons because otherwise if we are trying to traverse this graph like twice with one persons, we have to somehow mark the traversed way of this first person, right? That will be really hard to do. Instead, we can just use two players state, right? And to only traverse this graph twice, that will simplify the problem. And the only thing we need to be careful here is with two players, right? So, but when for the case two players ended up at the same cell, we only collect the cherry once, right? And other than that, like the other cherry pick number two, we just need to figure out from the current state how many different scenario combinations we have. So in this case, we have four because each players only have two options, to go down or go right. And for the other like cherry pick number two, uh, each robot or each player, each person have three options, right? So that's the difference here. And other than that, it's just this. Another thing is the minus one here. That's the other another difference uh, comparing this one with the other cherry pick two. So whenever we have this number one minus one here, it basically tell us we cannot move in this way. That's why we'll be using the biggest negative number to annotate this invalid path, right? And in the end, we simply return this answer here if there's something here, right? Uh, cool. I believe that's pretty much it is I want to talk about for this problem. You know, actually, I'm also thinking of like about if can we not using this biggest negative numbers? Maybe there's another way uh, of solving this problem. And but anyway, so uh, in this case, we just use this one to help us verify if the current path is a valid path or not, right? Okay, cool. I think thank you so much for watching the videos, guys. Uh, stay tuned. Hopefully, I'll see you guys soon. Bye bye.